Continuing our work on factorising and solving quadratic equations, this first example is a simple trinomial. So some of the things to remember: a negative sign in this position means that these signs in the brackets are different. So we want to consider the factors of 8. That will give us a 2. So numbers that multiply together to give 8 and add together to give 2. Well, that's quite simple. So we're going to have 4 and 2. 4 times 2 is 8. 4 take away 2 will give us 2. Now, we want a plus 2, and the signs are different. So we're going to have a plus 4 and a minus 2. Now, we've done that before. We've factorised trinomials before. The next step is where we set each of the factors equal to 0 and solve the resulting equation. So x minus 2 equals 0, x plus 4 equals 0, and x equals 2, and x equals minus 4. In this second example, we have a problem because we have an equals 12. If we're going to factorise and solve a quadratic, we must have equals 0. What do we do with the 12 then? Well, we'll take the 12 across onto the left-hand side. We'll subtract 12 from both sides. That means that x squared minus x minus 12 equals 0. So that's standard form for a quadratic. We've got the squared term, the linear term x to the power of 1, and the constant term. So we're going to have x and x. As with the last example, a negative in this position means the signs in the brackets are different. We want the factors of 12. I'm going to write the factors of 12 down. So it's 12 times 1, 6 times 2, and 4 times 3. All of these numbers multiply together to give 12. That's not the problem. The problem is which pair of numbers can be added or subtracted to give a 1x. Now the 1 is not written, but we understand that to be a 1. And in fact it's a negative 1, but we can take care of the negative in a minute. So which pair of factors can be added or subtracted to give 1? It's this pair here. The difference between 4 and 3 is 1. So we can put the 4 in here and the 3 in here. Now remember, it's a minus 1. From a 4 and a 3, how do we get a minus 1? And remember, the signs are different. So it's going to be a minus 4 plus 3. Next step then, x minus 4 equals 0. X plus 3 equals 0. Add 4 to both sides, so we've got x equals 4. Subtract 3, and we've got x equals minus 3. Third example, this one's in standard form. We have an equals 0, and we have the terms in the correct order. So squared term, linear term, constant term. So a positive sign in this position means that the signs in the brackets are the same and they're both negative, so that helps us. And we know that x times x will give us our first term, x squared. Now, what about the factors of 24? 24 times 1, 12 times 2, 8 times 3, and 6 times 4. Which pair of factors will add or subtract to give us a 14? There's no way we can get a 14 from these two numbers. 12 and 2, yes, 12 and 2 will give us a 14, and it's that pair that we're going to use. So x minus 12 equals 0, x minus 2 equals 0. We want to get x on its own, so I'll add 12 to the first one and add 2 to the second one. Example 4, things are starting to get a bit more difficult now because the coefficient of the x squared term is not 1. So let's see. positive sign in this position means that the signs in the brackets are the same and they're both positive. That's useful. Now, factors of 3. 3 is a prime number. 5 is also a prime number. So if I list the factors of 3, it's 3 times 1. And the factors of 5 are 5 and 1. Now, what I want to be able to do is to combine those in some way that gives me an 8. So we'll take the factors of 3 first of all, because 3 comes first in the quadratic. And the factors of 3 are going to feature in first position in both brackets. So 3 and 1 and 5 and 1. And we'll cross multiply. Now let's just see. 3 times 1 is 3. 5 times 1 is 5. From a 3 and a 5 I can get my desired 8. Now how do I take these numbers here and put them into the brackets? 3 and 1, so 3x and 1x, and then 5 and 1. Now what you might want to do in this example is to multiply out. So what have we got? 3x times x gives us 3x squared. 3x times plus 1 is plus 3x. 5 times 1x is plus 5x. And last term, 5 times 1 is 5. Now, it's the middle term that interests us. 3x plus 5x is 8x. So it would appear then, this is the correct factorising. Now, the next step is where we set each of the factors equal to 0. This one's nice and easy to solve. This one's a bit more problematic. So subtract 5, that gives us 3x equals minus 5, and then divide by 3. And there we have it. Example 5, this is quite tricky. 9x squared minus 6x minus 8. So the first thing we can say is that the negative in this position means the signs in the brackets are different. Let's consider the factors of 9. Factors of 9 are 9 and 1 and 3 and 3. And the factors of 8, that's 8 and 1 and 4 and 2. Now, we need to combine a pair of numbers from each set of factors to get the middle term. The middle term is the tricky one. It's easy enough to find two numbers that multiply together to give 9 and two numbers that multiply together to give 8, but when we combine those we have to get a 6, and we can deal with the negative last of all. So I'm going to take the 9, so one pair from each column. I'm going to take this pair and this pair. Now we arrange the factors of 9 on top because 9 comes first in the quadratic. So 9 and 1 and then 8 and 1, and we cross multiply and see what that gives us. 9 times 1 gives us 9, 8 times 1 gives us 8. There's no way that we can get a 6 from a 9 and an 8. Now before I scrap this pair of numbers, I can maybe change the order. So this doesn't help us. What if I write 9 and 1 and 1 and 8 and then cross multiply and see what that gives us? Well, that's even worse because 9 times 8 is 72 and 1 times 1 is 1. There's no way we can get a 6 from a 72 and a 1. So that pair is wrong as well. Now, I'm going to take, what we could really do is we've worked with these two. We could work with this pair, but I'm not going to do that. I'm going to go straight to this pair here. So 3 and 3, and 4 and 2. And if we cross multiply, let's see what we get. So 3 times 2 is 6. 3 times 4 is 12. From a 6 and a 12, I can get a 6. So this pair then is the correct pair. 3 and 3, the numbers that make up the 9, those must go in first position in the brackets. So 3 and 3, 3x and 3x. And then we've got the 4 and the 2. 4 and 2. Now, we know that the signs have got to be different. So one's going to be plus and one's going to be minus. And we want a minus 6. Now, we've got 12 here and a 6 here. So I'm going to make the 12 minus by placing a minus in this position. And we'll put a positive sign in that position because remember, signs must be different. Now if you want to multiply out the brackets and check, that's fine. Next line. And we set each of the factors equal to 0. Now we haven't discussed what this means yet, and that's okay. So we'll add 4 to both sides, and then divide by 3 to get x on its own. Here we'll subtract 2, so 3x equals minus 2. We'll divide by 3 to get the x on its own. Final example, example 6. Now this is interesting because we've got the x squared term last and the constant term first. The reason the x squared term is given last is because it's a negative x squared. There's no need to try turning the equation around. We can factorise it as it is. So in fact it's quite a straightforward one to factorise because the coefficient of the x squared term is 1. So we're going to have x in here and in here. Now we want the factors of 72. So 72, 72 and 1, 36 and 2, 3 and 24, 4 and 18, 5, 6 and 12, 7, 8 and 9, there we are. Why is it 8 and 9? Because we have to be able to get a 1x, so the difference between the two factors must be 1. 9 take away 8. Now we want a positive one, so the 9 has to be positive. Now the 9 is formed when these two multiply, the 9x that is, so this pair must be positive. There's no space in front of the 9 for a negative, so we'll put the negative in here. Sorry, the positive in here. And negative here. So 9 minus x equals 0. 8 plus x equals 0. Now what I'm going to do is to add an x here. Nine equals x, or x equals 9. And subtract 8